Hello everyone. As you all know, today we will be talking on Permanent Magnet Moving Coil or the PMMC instrument. My name is Kavieraj Anbualagan and my matrix number is 203706. Today I will be giving the introduction on the topic and I will explain on the working principle of the PMMC instrument. The PMMC instrument consists basically of a lightweight coil of copper wire suspended in the field of a permanent magnet. Current in the wire causes the wire coil to produce a magnetic field that interacts with the field from the magnet, which results in a partial rotation of the coil. A pointer connected to the coil deflects over a calibrated scale, indicating the level of current flowing in the wire. To learn how the PMMC works, we first need to understand deflection instrument fundamentals. A deflection instrument uses a pointer which moves along a calibrated scale to indicate a measured quantity. This can be achieved by using three forces which operates in the electromechanical mechanism. These forces are the deflecting force, the controlling force, and the damping force. The deflecting force works on the principle of electromagnetism. When a current flows in a lightweight moving coil pivoted between the poles of a permanent magnet, the current produces its own magnetic field in the permanent magnetic field. The direction of this magnetic field can be deduced by using right-hand grip rule. If we focus the left side of the coil, the magnetic field produced by the current carrying conductor and the permanent magnetic field cancels off each other at the top of the conductor, since the direction of the magnetic fields are opposite to each other. The magnetic field below the conductor is in the same direction and thus they will sum up to be a larger force. We can see that the net force below the conductor is larger than the net force above the conductor. This results in an upward force acting on the conductor. The opposite of this process will occur on the conductor on the right, since the current flow in the conductor is in the opposite direction. Since the conductor on the left moves upwards and the conductor on the right downwards, this will produce a rotation on the pivoted coil. The pointer is fixed to the coil, so it moves over the scale as the coil rotates. The controlling force in the PMMC is provided by spiral springs as shown in the figure. These springs retain the coil and pointer at the zero position when no current is flowing. When current flows, the springs wind up as the coil rotates and the force they exert on the coil increases. The coil and the pointer stops rotating when the controlling force becomes equal to the deflecting force. The spring must be non-magnetic to avoid any magnetic field influence on the controlling force. Phosphor bronze is the material usually used. That's the working principle explained. Thank you guys for staying up with me.
Hello, my name is Dineswaran Murugan and my matrix number is 202600. So now I'll be talking about the construction of permanent magnet moving coil.
The details of a PMMC instrument's construction are shown in figure 1. A permanent magnet with two soft iron pole shoes is the major feature. Only very thin air gaps occur between the core and the faces of the pole shoes due to the placement of a cylindrical soft iron core between the shoes. The lightweight moving coil pivots to move across these small openings in the air. To get the highest possible degree of magnetic flux through the gaps, the air gaps are made as tiny as feasible. One of the two regulating spiral springs is also shown in figure 1. The pivoted coil is attached to one end of the spring while the other end is connected to an adjustable zero position control. The zero position control can be modified to move the spring and using a screw on the instrument lead. When no coil current is flowing, this permits the coil and pointer location to be changed so that the pointer represents exactly 0 on the instrument scale. One of the 2 or 3 counterweights attached to the pointer is also shown in figure 1. This is merely a machine screw that can be used to adjust a small screw threaded weight. The counterweights ensure that the moving system is mechanically balanced, ensuring that the instrument's precision is not affected by gravity. A different style of construction is shown in figure 2 with the PMMC instrument. The permanent magnet is inserted inside the coil rather than in a horseshoe-shaped permanent magnet. The coil and the magnet are encased in a thick cylindrical piece of soft iron. The magnetic flux flows through the soft iron and over the air gaps, while the coil sides move inside the tight air gaps. The existence of the soft iron cylinder shields the moving coil from external magnetic fields, which is a major benefit of this core magnet kind of design. To cause the pointer to travel positively from the zero position over the scale, the current in the coil of a PMMC instrument must flow in one direction. When the current is reversed, the magnetic flux from the coil interacts with the permanent magnet, causing the coil to rotate in the opposite direction and deflecting the pointer to the left of zero. A PMMC instrument's terminals are labeled positive and negative to show the right polarity for connection, and the instrument is referred to as polarized. The PMMC equipment cannot be used to measure alternating current since it is polarized. It is solely a DC instrument without rectifiers.
Hi, my name is Kishan Kumar and my matrix number is 202744. So today I'm going to talk about torque equation and scale. Okay, so when a current I flows through a one turn situated in the magnetic field, a force F is exerted on each side of the coil. So from this we know that F is equal to BIL newtons, where B is the magnetic flux density in Tesla, I is the current in ampere, and L is the length of coil in meter. So since the force acts on each side of the coil, the total force for a coil of n turn is denoted as F is equal to 2BILN newtons. The force on each side acts as a radius R, producing a deflecting torque, where TD is equal to BILNR, and this can be better denoted here as TD is equal to BILND, as 2R is equal to D, as the R is equal to diameter, where 2 times the R is equal to radius, where 2 times the radius is equal to diameter. So and the D is denoted as the coil diameter, which is shown in the picture in the right. From this we know that the controlling torque exerted by this spiral spring is directly proportional to the deformation or wind up of the springs. Thus, the control torque is proportional to the actual angle of the deflector of the pointer, and this is stated as Tc is equal to k theta, where k is a constant. For a given deflection, the controlling and deflecting torque are equal, where k theta is equal to BILND. Since all quantities except theta and I are constant for any given instrument, the deflection angle is known as theta is equal to Ci, where C is constant. Alright, now we'll be moving on to application of PMMC instrument. So PMMC, or permanent magnet moving coil, is one of the best instruments to measure direct current. They are accurate, sensitive, and work for a longer period of time without defects and maintenance. These instruments on board are used to measure direct current and voltage. They can also be used as a galvanometer to detect small current or change in magnetic flux. So mostly PMMC instrument is used in ammeter, galvanometer, ohm meter, and voltmeter widely. Alright, thank you.